lot of us know about the core, the mantle, and the crust. Those are your big three that most people remember from taking an earth science class. This is actually a new layer. And when I say new, it doesn't mean that it's like newly formed. It's just newly discovered. And thanks to the seismic activities and research of the 1960s, which we actually did out of accident, we found that we had this layer sitting between the crust and the mantle. We call that the asthenosphere. And the asthenosphere, remember we said that the mantle is completely molten? Well, the asthenosphere is like this really weird upper, and it's solid, but not. It's solid. Completely solid. But it's moldable. Okay, it's plastic. We say that things are plastic or something has plasticity. What that means is it's able to be bent and molded and shaped. Okay, that's our asthenosphere. Completely solid, but able to be molded. And it's kind of like slime. Alright, so for those who have never made slime before, if you made GAC before or played with GAC, you guys remember that stuff as a kid? Okay, it's very similar to that. Very gooey, but yet it's completely solid. And basically that's this little tiny upper part of the mantle. And what we have, and that's what I'm passing around right now, is a very unique type of rock called olivine. And so the asthenosphere has this mineral called olivine. In fact, in the sample that's coming around, you guys will notice that it has gray. Right, so if you guys look at that, that's not where I want to go. So we have the gray portions right here. And that's basically the volcanic ash. And then you have the actual green mineral that kind of juts out from the ash. What this tells us, when you have a volcano that erupts with olivine, that tells us you have a very, very powerful volcano because that magma isn't near the surface. That's a very, extremely deep magma source, which means it's coming from all the way deep within the asthenosphere. So that, again, when we're looking at volcanoes, we get a lot of information. And this is, like I said, this is one of those central themes to the course, where we look at rocks, and the rocks actually tell you a bigger story than what you could ever imagine. There's so much information you can take out just looking at the rocks. And so, like I said, when we're looking at that volcano that erupts with that type of material, that tells us the source of magma. And generally, with that source of magma, we have a lot more violent eruptions. That's a very key sign of violent eruption. So when geologists are basically doing studies around volcanoes and they find a bunch of olivine, that tells them that that volcano's had severe eruptions in the past. And then they can start trying to date those and seeing if there's any way that they can find, is there a repetition between the times of those eruptions? And that's kind of an important thing to know about. Finally, we have the crust. We made it all the way out from the asthenosphere. We're back out to the crust. And ultimately, all you need to know about the crust is the thinnest layer. Now, everything else we talked about today has been pretty thick. The core is about 1,000 miles. The outer core is another 1,000. And then the mantle is another 2,000. So how thick do you think the crust is? 25 feet?
No, 25 miles.
25 miles. Hey, what else? It's a good time for you guys to actually interact here. How deep do you think the crust is? How thick?
27 miles on average.
27 miles on average. Let's look that one up. On average. Okay. Anyone else? Thick enough, yes. About 70 miles. 27 on average, but at the thickest place, 70 miles. Where's it the thinnest? Where is the Earth's crust the thinnest? At the bottom of the ocean. Alright. Underneath the mountains is where it's actually the thickest. And we'll see images of that. Not today, but later. Alright, so I want you guys to put things in perspective. We've drilled down pretty far. And we've had caves that have gone down pretty far. In fact, one of the deepest caves, when you go down there, you have to wear a life suit. Because at that depth, the average temperature underground is upwards of 115, 120 degrees. That also means that the rock that you're about ready to touch with your bare hand is also 120 degrees. And so it's just a little warm. So we've gone down pretty far. Now the crust is 70 miles. I want you guys to take a couple moments. I want you to confer with your partners. And I want you to make your best estimate. So no research online. I want you to make your best estimate. What you think, based on the fact that we've gone down pretty far, based on the fact that at its thickest, the crust is 70 miles. Understand, guys, we've gone down layers far enough to get oil. We've drilled beneath the ocean floor to get oil. So, I want you guys to consider these three questions. Deepest mine, cave, and how far have we gone down to the deepest drill? We had 2 minutes to discuss that. How far are we mined underneath the earth? Any ideas? 150 what? Feet?
Miles.
Crust is only 100, or it's only 70 miles.
Oh, sorry, 200.
200 miles? Let's make realistic guesses here.
90?
47.
55 miles.
Oh,
45.
45 miles.